Hi, guys, and welcome back to another episode of Women in Math and STEM, where our mission is to reach out to as many professionals, aspiring professionals, students, whatever you name it. We try to reach out to them, who essentially support the initiative of bringing more women and young girls into the STEM field. So, with that being said, as always, feel free to open up the description or transcript to better follow along, and I hope you enjoyed this episode. Okay, hello. Thank you so much for coming to this call and talking with me today. Just to start off, could you briefly introduce yourself as well as sort of explain how you got to where you are today?
Okay, Angelina, that is going to take a long time because I'm pretty old. But yeah, my name is Bruce Bailey. I am currently a Peace Corps volunteer working in the Volta region of Ghana. I'm teaching junior high school math. And before I was in the Peace Corps, I had a long career as a math professor at the University of Arizona in Tucson, Arizona. And before I did a lot of fun things while I was in Tucson, and also traveling the world during my time as a math professor. Before I was a math professor, I was a research assistant at New York University in New York City. And that was a lot of fun. Before I was a research assistant, I was a student. I was a graduate student at Princeton University and MIT, and I studied applied math. I studied fluid mechanics in particular because it's well, fluids are physical things and they are in the world. So studying fluid mechanics isn't like abstract pure math. But we know the equations, and so you can be studying fluid mechanics your entire life just by working on the equations as a math person. And there are other scientists who study fluids by doing experiments, and they're physics people and engineers and so on. But I was I was studying fluids through the equations, and and I still do study fluids through the equations. Back before I was in grad school, I was in undergrad school, and I got a degree in math. They just called it regular math from Cambridge University in Great Britain. And I used to tell people, in fact, I still do tell people, that I used to be roommates with Isaac Newton. And nobody believes me completely, but it really is true that one time in the hallway in Cambridge, Stephen Hawking was coming along in his wheelchair, and it was kind of crowded, and he ended up rolling over my foot in his wheelchair. It wasn't, there were no injuries. It wasn't a heavy wheelchair, and he wasn't a heavy guy. But I did have that interaction with Stephen Hawking, even though I didn't have an interaction with Isaac Newton. Um, and before I went to college, before I went to Cambridge University, I was back here in the U.S., but I was in upstate New York. I grew up out in a little village called East Greenbush, which is near a small town called Troy, which is near the state capital, which is Albany, which is a medium-sized city. So I've always been in pretty small places, except for the time when I was in New York City. So that's and I guess okay. So maybe I should say that I was born in 1961, and so that makes me 63 years old now in 2024.
And then I think you mentioned that you studied both fluid mechanics and math. What sort of got you into either or both?
Oh, okay. Um, yeah, yeah. So I guess how I got into math. When I was okay, yeah, I mentioned that I was born in 1961, so that meant that in like late 1960s, early 1970s. That was a long time ago, but um, most people had radios and TVs, and there were a few people that had two-way radios, like walkie-talkies. If you were a kid whose family had some, could buy you expensive toys, they could buy you a set of walkie-talkies, and you could give one to your friend, and you could be like in your house down the block, and they could be out in the backyard, and you could have a conversation. It was really cool. And my family wasn't quite that wealthy, so they weren't just going to go out and buy me a pair of walkie-talkies, but but they said, hey, if you learn some electronics, and maybe you can build some. And I thought that would be a great idea, because that was the kind of thing that kids did back then. Nowadays, kids will like get on the internet and start coding and building robots and things like that. Lego robotics is a big thing if you're in elementary school. But electronics kits were a big thing 50 years ago, and so my folks got me an electronics kit, and I thought that was really exciting. And I built like little things like a light bulb that would turn on and off, and a buzzer, and even a little electric motor. But I was never able to build the walkie-talkie to make the two-way radio. I think maybe I wasn't as careful. It's a complicated thing, and you have to be good at working with small things and making connections and not breaking things and stuff like that. So anyway, I had fun with electronics, but I wasn't very successful. And so when I was in middle school, I was thinking, what could I do? I like electricity. I like, I certainly enjoyed learning about it and how it worked. And so I guess that was how I got interested in, physical science, because of electricity. And then I guess I kind of also gravitated to math. One thing that took me towards math is that my family went traveling when I was in 8th grade. My dad had a job. He was a teacher in upstate New York, and he had managed to get a year exchange teaching in France. So that was cool. So I was happy to skip school for a year, or almost a year, from upstate New York. And I did go to a school in France, but basically I just tried to sat in the classroom and tried to pick up French, and they did. They didn't care that I wasn't like taking the classes seriously or anything. But I had a book that was about like the history of math, and it started with Egyptians and Greeks and the Arabs and the Hindus with the Hindu-Arabic number system and things like that. And I thought this was really, really interesting. And this was a year when I didn't have electronics or anything like that to mess around with. It was basically just me and this book with a history of math. And I thought this seems a lot more interesting than actually like learning math in school. And, yeah, I mean, we were doing fractions and percents, for heaven's sakes. So two things happened. One is I discovered that math was more interesting than I thought, and I also discovered that you can learn a lot. You can have a good time with math, kind of on your own by reading things and kind of following up stuff on your own. And then when I went to high school, I found that again they were not trying to teach me the most interesting stuff. They were it was algebra, and algebra is not the most exciting subject. I mean, it's very important, and it's our key to It's the key to our modern world. It's how we figure out stuff. But um, but I was able to read ahead. I had a book about geometry, so I read ahead about geometry and triangles and sines and cosines and stuff. And so because this was New York State, we got they had an exam, a big exam at the end of the year, a Regents exam. And if you took the Regents exam and you passed, then you passed the math class for the year. And so I just started taking the Regents exams while I was in high school, and I managed to get through high school math in like a couple of years, just by basically reading the books. And then I started taking classes in the college that was in Troy, in my hometown. Angelina, did you ever hear of a college called Rensselaer? There's a lot of engineers that go there.
I think I might have, but I'm not too sure if it's the same one I'm thinking of right now.
Okay, anyway, it's in Troy, New York, and it was really close to where I lived. That was the place where my dad was teaching. So it was very easy to take classes in math, and I even took a physics class when while I was finishing up with high school. So and I think this is this was a little bit unusual 50 years ago. Most people, when you were in high school, you stayed in high school. When you went to college, then you went to college and you were in college. But nowadays, there are a lot more. There's a lot more kids. Maybe you are one of them, who who take college classes or college level classes, maybe at the community college, or things like that. Or maybe you can even take a class at your high school for college credit. There's a lot more, a lot more possibilities like that, if that's the kind of thing you're interested in. And yeah, so that's kind of how things went when I was your age. Okay, not quite 50 years ago, because you would have been in middle school, but almost like that.
Your path seems really interesting. I was just wondering, when you got to college, what was sort of your inspiration or motivation for pursuing like math education?
Oh, okay. Oh man, a couple of inspirations. First, um, I okay, yeah. So when I first when I was first going to college, um, it was much more interesting than than high school, and I had teachers who were a little wacky sometimes, but they were really excited about what they were doing. And I found that it makes a real difference to a class if the teacher's exciting, and if they're like enjoying what they're doing and they're talking about what they're interested in. And so I decided that yes, that would be if I became a teacher, then that was the kind of teacher that I'd like to be. And because things ended up, even though I was a math major, I never lost interest in like electricity and physics and how things move and stuff like that. So whenever I had a chance to take a class that was involved in that had some math, but it had some physics, it had like things and equations, I would take those. And sometimes those classes would have, the professor would come in and do something like live in front of the class, or maybe we'd have a lab. Labs weren't awfully exciting because usually they had they kind of told you what to do and then you would do it. But when the professor had chosen to bring something into the classroom, it was a little bit more unusual. So that was I got the idea that okay, yeah. So I got two ideas while I was a student. One was that it's good to have teachers who are excited, and that one of the things that makes a class exciting is to like bring fun things into the classroom. And so when I got to be a teacher myself, I did start trying to make my classes interesting, trying to make them fun, trying to make and if a student was saying, Dr. Bailey, what is this math good for? How will it help me? When will I use it? Then then I wouldn't have to like say stuff. I could like show them stuff, and and then I'd so that would be and sometimes it wasn't very complicated. Sometimes I would have like a spring that you could stretch, and there would be like something heavy on the end, and it would bounce up and down. And I'd say, like, check it out. See, it's bouncing up and down. How fast is it bouncing up and down? Why is it bouncing up and down? And then we do things like that. And all through my career, I would still take into the classroom springs with like lumps of stuff on the end, and have them bounce up and down, and we would talk about them. Lots of other things as well. But yeah, and so it began. I began by copying things that my teachers had done and things that I'd seen. But then I would like run out of, I would do those things, and then I'd run out of ideas. And then I would say, okay, now I need to spend some more time coming up with more ideas, and like researching what other teachers have done, and maybe I need to invent some of my own. And so from teaching and from thinking about how to make teaching fun and interesting and stimulating curiosity, I kind of ended up spending a lot of time thinking, trying to think creatively and coming up with my own ideas, and spending a lot of my actual working time on that kind of thinking. So that was kind of how I got into doing educational work, as well as my research on fluid mechanics.
I think you might have
Oh,
touched on. Oh, sorry.
Oh yeah. I think maybe you're about to ask, but you remember that I was talking about electricity and magnetism and things like that, as well as fluid motion, and just kind of like by taking a class in college, I discovered that in astrophysics, when you have something like the sun or the galaxy or a big planet like the Earth or Jupiter, they have inside them fluids that flow around, but also that conduct electricity. And so like inside the center of the Earth, there's liquid metal that flows around, but there's electricity, and the electricity makes a magnetic field. And that magnetic field is why we can take a compass outside and it points in a certain direction. And so I ended up, part of a lot of the fluids that I was thinking about were regular things like water or coffee or air. But some of the fluids I was thinking about were like liquid metals or the very, very hot gases that are inside stars and galaxies. So that's one of the cool things about math, is that once you have the math, you can use it in a lot of different places and a lot of different situations. And sometimes there's situations where you can't always do anything else, but you can still do the math. Yeah. Anyway, you were about to ask me another question, and we will go right there.
Yes, I hopefully you don't mind, but I was just wondering, I think you might have touched upon this a little bit, but you've taught both at a university as well as with the Peace Corps, like currently. Just wanted to know what's been your favorite part about teaching, like at places. Yeah.
I love teaching, and I have I certainly had a great time as a college teacher for many years, and I'm having a great time as a junior high school teacher, middle school teacher now. It turns out that when I was a student, I didn't have a whole lot to do with people younger than me, but then when I got to be like in the middle of my career, when I was like 30 something, and I had children of my own, I discovered that I really liked, you know, working with young people, and um, even though I was talking about math that I already knew, if I got to talk about math with with people that didn't know it, like my students who were seeing it for the first time, then it was like discovering it again. And so that was always fun at the university. And now that I'm back at junior high, I am right back with that history of math book that that got me psyched. Like literally 50 years ago, over 50 years ago. That got me interested in math. That when I was in middle school, and so I'm like, I love the Pythagorean theorem. I love that if you cut out a triangle and you cut out the corners and you line them up, then it gives you 180 degrees. And it took people thousands of years to really figure that stuff out, because if you don't know it beforehand, why would you do that? And it's pretty amazing. I'm still not that enthusiastic about decimals and fractions and percents, but but I love going back to the basic math that all the rest of math is built up on. And and so okay, to answer your question, I discovered that I enjoyed that with college students, and I enjoyed it with the younger kids as well.
And then sort of as a final question, do you have any pieces of advice, recommendations, or suggestions for younger students who want to pursue math or math education in the future?
Oh my gosh, totally. And I see, yeah, this was the last question on the list of questions that you gave me. So I hope it's not really the last question, because I've been having a ton of fun chatting with you about stuff. But if it's oh my gosh, I can see it's almost 3:30. So if you're going for a half an hour, then that is also cool. Yeah. So I would say that you've probably already discovered that math has fun parts. I mean, it sounds like you're interested in math, and it must have been fun. It must have been fun along the way. Maybe it's been fun a lot of the way. Maybe you've had fun teachers that do that. And so my advice is, I can have two pieces of advice. One is to keep having fun in math, keep finding fun things in math. And there are it's great if you're enjoying your math courses, but there's a lot of math classes which are not fun, just because either it's fractions and decimals, which are very important, but but hey, not the most exciting thing. Or other people, maybe some people, maybe you like fractions and decimals, but not everybody has the same, gets excited by the same things. There are a lot of sources, especially on the internet these days, that really say, hey, let's do some fun math. Here are some math games. Here are math puzzles. Here are math YouTube channels, where different people have different. They just talk about the things that they like about math, and if you find, I didn't have that stuff when I was a kid. I only had this one book, which luckily was a good book. But now there's many more resources and different kinds of things that you can choose. And even if you're busy with classes because you're in your I forget, what year are you in high school? Junior, senior?
I'm a rising senior.
Oh my gosh. Okay, so maybe you just came off a really busy year. Your junior year is full of stuff, and senior year can be full of a lot of stuff too. But you might still have time to do some fun things and find some fun games. And I should say, I want to brag just a little. My school, my students and I, we came up with a whole new fun game ourselves this spring, and it was a lot of fun. It's actually not a completely new game. It was like an old game, and then we added a new twist to it and made it into a new version of the old game, and it's a lot of fun, and it helps kids practice addition, so that's fun. And yeah, and so I'm here to say that you can take time off, you can watch math YouTube videos and do math puzzles, and you are not wasting your time. You were, it's okay. And then and then when you go to college, I don't know if you're thinking about being a math major, but are you thinking about being a math major when you go to college?
Yes, hopefully.
Okay. So being a math major is a great major, but it's also, if you decide you want to be a different major, then being a math minor is a great thing to do, because if you decide you want to be like physics or engineering, that's a great major, and then there are great jobs, and then you have engineering is very exciting because you design something and you make something that nobody has ever designed or made before, and if you're an engineer, you can save lives, you can improve the lives of millions of people. So there's great things about being in engineering. You have to learn a lot of math if you're an engineer, and that can be your chance to have fun also if you like math, or if you decide you like economics and finance. The business world is very important, and there's also a lot of money in it if you get a job in a financial services company or as an actuary. And those jobs are challenging and interesting and fun too, as well as you make a lot of money. But you also get to take math classes along the way. So I feel like math will be part of your future, even if you're not a math major. And you can also be a math major, and then when it comes time for you to you can go to grad school in math, or you can decide you can go and get a job because you need a break from school. A lot of people find that by the time you've gotten a bachelor's degree in math, that's a lot of classes, and you want to do something else. A lot of young people decide they want to join the Peace Corps after they've gotten a bachelor's degree, and and that's I did not do that. I went to the Peace Corps after a career as a math teacher. But if you have a math major, then you will often get hired by like a business or a financial services company or an engineering company, just because you're good at math. And if it's like a computer company or electrical engineering, you learn that from the other people that you're working with. You help them with math, they help you with the engineering. Your education doesn't stop just because you're not in school anymore. Sometimes the biggest part of your education is that first job you have out of school, and you learn all the things that they didn't teach you in college. So, so that's who knows whether that's in your future, but it's okay not knowing at this stage what's in your future, because you just have a lot of possibilities, and part of the excitement of being finishing up high school, thinking about college, is keeping your options open and just seeing what might lead, what might happen.
If you don't mind me asking, I think you mentioned like a game your students and you could.
Oh yeah.
I just wanted to like ask for an elaboration if you don't mind, because I'm really excited. I want to know more about this.
Okay. So first I would like to uh can I share my screen for a moment?
Oh, yes, let me turn on permissions for that.
Yeah, sure.
Okay, it should work now.
Oh, yeah, okay. Oh, and Angelina, um, this we'll stay online and we'll talk about this fun game. Um, for the purposes of the interview, um, I'll just say a couple of things about it right now. Then you can like stop the recording for the interview, and then we will go and we'll go and look at the game. We'll spend like a while looking at the game, and then you won't you won't have like a whole lot of footage that you don't know exactly where to put. Okay, so um, listeners out there and Angelina, um, there was a game that was invented by a couple of mathematicians over 50 years ago in like 1969, and the name of the game is Sprouts, and it's real simple. You can play with a piece of paper and a pencil, and you don't need anything else. You don't need squares. You don't need pieces. It's just a piece of paper and a pencil. There's dots, and you draw lines, and you draw more dots, and the lines can't cross each other. And eventually, you get to a point where nobody can move anymore, and nobody can draw any more lines without them crossing. And the person that drew the last line is the winner. So that's a pretty old game, and it's been around since the 1960s. And I was teaching this game to the other teachers at my school last March because Pi Day was coming. March the 14th was coming, and we were going to have some fun games to play with the students at my junior high school. And so I was explaining this to the English teacher, and she likes math, even though she's an English teacher. And she said, if we just give these dots numbers, and every time you draw a new line between two dots with different numbers, and then you add the numbers from the old dots and you give that the sum to the new dot, then the kids will get they'll practice their math while they're playing the game. And I said, oh, but yeah, that's brilliant. Let's do that. And so that's what we did. And the kids loved it, and the teachers loved it. And since that day, that was on Pi Day. Since that day, I've shown other people and told people about it in the U.S. and people like it. And I guess basically the most important thing about that game is that you can invent a new game and have fun playing it. And it doesn't matter if you're in middle school or elementary school or you're like an advanced mathematician. That is, you can be having fun with math and being creative with math at whatever age. So, hey, that's probably a great way to end our interview. So let me say thank you for thanks for having me, and you can cut the recording, and then I will just stick around and we will look at the game.
Okay, thank you so much for coming to this call. It was really fantastic talking to you.
Well, yeah, likewise.